Welcome back to class. Today we're talking chill water system and the final. So we'll go through chill water system and then we'll should go through the final. We have talked about the refrigerant process in the past, and so we'll just start there, right? So we're talking mechanical compression refrigeration. And if you remember in the past, we talked about this a little bit where we've got the compressor and the condenser, and that's outside of, we're just talking at like a residence, a home, right? So the compressor condenser is sitting outside, and there's a little compressor surrounded by a coil, and the compressor compresses a gas refrigerant, and it compresses it into uh, high pressure. And as it goes around the coil of the condensing unit, it starts to cool off because air's blowing across it, right? Let me turn this my laser pen on, laser pointer. There we go. So the refrigerant is compressed as it starts to go through the coil around the condensing unit. Air's blowing across it, cooling off the pressurized refrigerant, which then turns into a liquid. It goes through a phase change, and going through a phase change, it gives off. In order to go through that whole process, it gives off a lot of heat, right? So uh, in this example, we're saying that it's coming out pressurized at 182 degrees Fahrenheit, and it's leaving as that's a high pressure gas. Now it's leaving as a condensed liquid at condensed liquid refrigerant at 95 degrees, going back to the expansion device, going over to inside the house, right? So we're kind of like inside the house somewhere right in here, and this is the coil inside the on top of the furnace, called the evaporator section. And so that refrigerant goes through an expansion device. That liquid refrigerant is now not under so much pressure, and it wants to make a phase change back to gas because it's lost a lot of its pressure. But it also needs heat in order to make that phase change. So it's sucking heat right out of the air blowing across it, which is getting blown over to the home, right? So it's pulling heat out of this air so that it can help make that phase change and turn into a gas refrigerant again. And now it's leaving at 52 degrees right here as a low pressure gas refrigerant back to the compressor to start the entire cycle again. All right. Now, if you think of like another way to do this, what if we sent the refrigerant gas through the compressor, and it going through the condenser here, and rather than blow air across the coil, what if we took cold water and pumped cold water across the coil somehow? What if we had like a tank of water right here, and that what is that? That's not what I wanted. Oh, okay, we'll do it with this. I have no idea why it did that though. I'm a little curious. Okay, we'll just do it with the next slide. So imagine this section right here. Instead of refrigerant going in through the condenser and having air blow across it, what if it was a liquid? Okay, and think about the same side over here. Imagine we went and did compress this refrigerant, cooled it off with water instead of air, and then sent it back over to this evaporator section. And what if, rather than trying to cool air, we just cooled some more water and sent the water off to somewhere that was really cold, like a coil inside of an air handler? So imagine this being cooling water, not cooling air, pulling the heat out of the water as it makes its phase change from uh, a liquid refrigerant to a gas refrigerant, and from high pressure to low pressure. So imagine it trying to still all its heat, not from the air, but from water. Hi, buddy. Okay, so now let's look at my next slide. So that's my introduction to chilled water out. So the idea of, let's go back. So if we're cooling off water, that would be going out to an air handler. We'd have. I'll show you this in a second, but I just want to use this as an example, and we'll come back to it. So imagine something like this on each side, and now let's look at our chiller. And I remember when we first talked refrigerant, we had this schematic up, and I was trying to say like this is impossible to talk about without having a heat exchanger and an air handler. I wasn't giving you enough components to be able to just describe a chiller. But imagine one section being a condenser, the other section being the compressor, and the idea here is that here we need to. It's the same cycle as refrigerant, but we're not using air. We're using liquid as our. We're creating chilled water out of this side, and we need to waste our heat out of that side. So go all the way back. Let's go back. We're cooling air in this graphic on this side, and we're heating up air on this side, right? Because this is outside and we're just blowing air across a very hot uh, refrigerant line that's getting compressed and trying to turn into trying to condense and turn into a liquid under high pressure. And on this side, we're just cooling air because we're doing the exact opposite. We're taking compressed liquid refrigerant, moving it under low pressure, and letting it expand into a gas, and it steals all the heat out of the air. Well, that's really what's going on in a chiller as well, but instead of cooling air and heating air, it's cooling water called chill water, and it's heating water uh, called cooling water. Chill water, cooling water. Okay, let's look at this real quick. So we've got an air handler. This is a schematic of the air handler, and it looks like a lot, so but it's really not too bad. It really isn't. You guys should recognize this. We have the return air, a ductwork here, right? And then we got some fans, and they're running off VFDs, and we know that VFDs are variable frequency drive. And my little guy's over there talking in his room, so forgive me if you can hear him. And then we've got the relief air. So some of the air needs to get shot gone out to the atmosphere, right? So we don't want to return 100% of the air back to the space that we're trying to heat or cool. So some of it kind of gets exhausted out, called relief air. And then we have this outside air, which is sort of like the makeup air to this place. I mean, to this, so we're able to get some fresh outside air to mix in. So we've got the return air going this way. Some of it goes that way. Return air comes this way. It mixes with the outside air. And now we've got some pressure stuff across the filters. Right here we've got glycol hot water supply coming in here to this heating coil, and then back out to so we have a boiler loop right here. So we have a boiler somewhere providing hot water in a glycol water mixture, glycol hot water going into this coil and out, right? So this is big air handler, got a heating coil. Then we've got a cooling coil number 1.2 and a cooling coil 1.1. So this air handler has two cooling coils in it. Not a big deal other than it has two cooling coils. There's a large demand for cooling. So we're going to ignore this one for now because it's a different type of cooling coil. But there's our chill water supply, chill water return. Do you see that? CHWS, chill water supply. chill water return, and it's got a way to modulate how much chill water is coming into this coil. So we've got that guy coming in here, cooling off this coil. Air comes across that, and it comes across that coil and cools off. The air cools off, and it sends cool air to the building, right? So we've got chill water supply, chill water return. Now, where did the water come from that got cooled off? It got cooled off at the chiller. But I need to show one more step, that the chiller needed to be able to cool off, to waste its heat somewhere. And in the system I'm talking about, it's going to waste its heat at a cooling tower. So let me see if I have another slide here. Here's our cooling tower. But I don't want to use this other than to show we've got this cooling tower. Let's bypass this one, and we'll go look at my blue beam example. Very, very simple. We've got our chiller in the middle of this little schematic, okay? The condensing side and the evaporator side. The evaporator side, it creates chill water. This is the refrigeration cycle again. All it is I'm not showing that whole cycle of refrigeration, but that's the whole refrigeration cycle going on here. And we've got the evaporator section over here, and that's going to create, that's where the high pressure refrigerant is turning into, allowing it to go to a low pressure refrigerant. So it's high pressure liquid refrigerant turning into low pressure gas refrigerant, which is going to do that phase change from a liquid to a gas, and it's going to like steal all the heat out of somewhere in order to make that phase change. Well, it's stealing all the heat out of this water supply. We have a pump pumping water to my little air handler schematic here, to the air handler coil, the chill water coil. A super simple schematic I drew up. Took me a few minutes. Hopefully that's okay. As the water goes through the coil and air goes across that coil, theoretically the air is hotter than the coil, so it's going to heat up the water in the coil. And so the return line back to the chiller, the chill water return line, is going to be warmer, and it's going to need to get cooled off again at the evaporator. So it's just this loop, chill water loop. And what would you be calling this right there? Heat exchange, heat exchange, heat exchange, heat exchange. It's all heat exchange. Even though we're not necessarily talking about temperature, like hot, we're just talking about moving heat from one place to another. We've take mechanical energy to turn something cold here and then move that heat into a coil so that the air blowing across that coil can get cooled off. And then just by way of cooling off the air, the heat had to go somewhere. So the heat went into the chill water. It went into the coil and into this chill water return line, and it goes back to the evaporator to follow the cycle again. Now we need heat exchange here as well. So our condenser, evaporator, condenser. Now our evaporator and condenser, that's the refrigeration cycle. And when I said we need to do something, there's our little chiller, there's our little air handler. This is the part I wasn't able to talk about when we first introduced refrigerant. So this condenser evaporator side, so let's just think through it for a second. We got the evaporator. This has got the compressor. The compressor's the compressor's over here. It's taking refrigerant that's just made a phase change. It's low pressure refrigerant, and it is going to compress it and put it through something so that it can turn from a high pressure gas to a high pressure liquid refrigerant, right? So the refrigerant's coming from the evaporator side as a low pressure refrigerant gas. It's going to get compressed and go through a condensing cycle here. It's going to try and turn into a liquid. And it needs to give off its heat somehow. It needs to give off its heat, and it's going to go through this cooling tower. So we have this schematic of my cooling tower out here, and I'll talk about it in a second. But imagine another water to refrigerant interface there. So we've got kind of going back to that schematic that I had here. Where is it? Now this is showing uh, the evaporator side, but basically the same idea is that we've got somewhere with liquid and or refrigerant, and it's gonna get we've got a coil with a bunch of water in it, and so they just drew it as a box here, and that's fine with me for how this is supposed to look. But think of our condensing coil being cooled off with water here. The water is going to get warm. We're going to send the water to a cooling tower, and it's going to cool off and come back a little bit colder so that it can then help that refrigerant condense. It's going to pull heat out of the, or yeah, this is colder, so it's going to pull heat. Let me think about that for a second. Yeah, this is going to pull heat out of the compressed refrigerant gas and allow that compressed refrigerant gas to make that phase change. So it's going to pull that heat out so that it can make that phase change to a refrigerant liquid and then come back over to the evaporator side as a high pressure liquid refrigerant. So we've just got that whole cycle. So you've got three loops or two. Well, I don't know. You could call this a loop, I think. You got a refrigerant loop, you got a chill water loop, and we got a cooling water loop. So we need to go look at what this cooling tower is. And there's a lot of different versions of a cooling tower, and we'll come back to this. Let's just go look at pictures of cooling towers. Uh, there's pictures of lots of cooling towers. So the cooling towers I was kind of referring to would look more like this. These ones over here or that one right there. And if we went and did like, let's go look at um, Google Earth. And hopefully it's where I was before. This is what you want to do on a lecture, right? Wait for, yeah, perfect. Okay. So, do you guys recognize that's Weber State Davis? That right there is cooling towers. So there's cooling towers here, there's chillers in here, and the air handler is right here. Or there's multiple air handlers, I can't remember. But what it's got is there's underground piping going all the way up in and up this building, up into this penthouse up here, up on top of the building where the air handlers are. I think there's more than one, and it's moving the chill water through this pipe all the way up to this coil. There might be, uh, I'm probably oversimplifying it, and forgive me if you're like Michael, you're not talking about all the little details of heat exchange and stuff, and you're not, and I'm trying to keep it simple. It's okay. Just imagine this chiller cooling off water and the water coming up and cooling off a coil in one of these air handlers and coming back underground in this tunnel back to the chiller to get cooled off again so that it can go back. So you have this loop here, right? And then the chiller, the condensing side of the chiller needs a cooling tower, which is right here, to cool off the condensing side so that it can sit there and do its job. It's just a really big version of the same cycle that was going off with uh, the compressor, condenser, evaporator at your house. This is just a much bigger version of it. So let's go look at how a cooling tower works a little bit. And I found this website here, Cooling Tower Products. So imagine water from the chiller on the condensing side, the water on the chiller. So let's go back to my talking about right here. We have our chiller, we have the condenser. The water coming from the condenser is coming to a cooling tower, and it's hot and it needs to cool off. So it comes in the top hot and it falls down and it gets cooled off and it lands in this basin and then it gets pumped back to the condenser. We're going to go look at that right now again. Okay, so it's coming from the condensing side of the chiller hot, and it has these spray nozzles or a distribution system to be able to spray that water and trying to get it to mist a little bit and have more surface area in the water. The water is going to get sprayed onto this what they're calling fill material. Now I've seen it lots of different ways, but imagine that being like something similar to what you might see on if you cut a cardboard box and you sliced it down the cardboard box and you saw like the little ribs and stuff in between the two fins. It kind of looks like that a little bit. You might see it sometimes looking like the media pads uh, on a swamp cooler, something like that. Okay, so we've got water coming down that's hot, and we've got air because there's a big fan up here. Big fan, big fan trying to just push air, and the air's coming in from the sides, and the air's getting pushed across this water that has been in this spray nozzle to try and get the surface area of the water to have a lot of surface area to it. And so air is going across this large surface area of water, and the air is going to make some of the water start to evaporate. And the evaporation is another phase change, is it not? Liquid to gas or liquid to vapor. In order to make that phase change, it's going to need to get a lot of heat in order to make it. So how does the water get heat in order to make the evaporation? It steals the heat from the water surrounding it. So the water that continues and doesn't evaporate ends up being colder and lands in this collection basin and then goes back out to the chiller condensing side to be able to cool off that chiller. Okay, I hope that made sense. I'm hoping you're seeing hot water coming in, it get water being dispersed in a way to increase the surface area of the water, air going past it, air picking up, air being less, having less, what's that word? Humidity, I guess. Is that the right word? The air going across it is less humid as it comes in than it is going out. And so it picks up a lot of humidity in the form of vapor or gas, liquid gas. I don't know how you call it, water gas in its form of vapor. And so in order for that water to make that phase change, it's going to steal heat from the surrounding water around it. The water that continues past and uh, doesn't evaporate ends up in a collection basin much colder than it was when it first came in. And that's going to go back out to. They have a pretty cool little graphic, right? I don't want to steal their stuff, but I think they have a good graphic in here if I remember right. Maybe it wasn't there. Maybe it was turned. Where did I see that? No. A bunch of train chillers. Where's that? There's our. Ah, here we go. So this is another schematic from a website that, whatever, I'm just trying to give you different versions of the same thing. We've got our air handler, fan coil units, etc. as the cooling load. That's in the building. We got a chiller, both two sides of a chiller, evaporator and a condensing side. The evaporator makes the chill water. Here's the refrigeration cycle going on right here. On the condensing side of the refrigeration, it needs to be able to cool off, so it uses water going back to the cooling tower uh, to make that loop. So there's a loop here, and I would call this one a closed loop, as well as the refrigerant is closed loop, and this is an open loop because you're actually losing water through this process. So you're gonna have a makeup water somewhere to add more water into the system right here, so it's not closed. All right, let's uh let's go make this a little more difficult, a little more. Um, let's go back to PowerPoint. There was another version of this. We'll go back to PowerPoint in a second. There's air-cooled chillers as well, but I chose liquid-cooled chillers. So the what I'm going to report on is I'm going to make a report for my final about chillers and cooling towers, and in order to do and mainly talking about the system of chill water. And I'm going to pick the two main components that make the chill water, and I chose a chill water system. I mean, a water cooled chiller system rather than an air cooled chiller. But this could be, instead of a cooling tower right here, it could be a bunch of. We've done this before where we had this. Um, it could be an air cooled chiller is all I'm saying. And let me bring up a set of drawings to be able to do that. Give me just a second. Put this on pause and I'll come back with it. Pause. All right, I've got this drawing up, and now I'm confusing the matter because I want you to understand that there's more ways to do it than one. I'm originally saying here's our cooling tower. This right here, CH1 and CH2 is our chillers. Our air handler is above this space, so we're not actually seeing it. We're seeing the piping layout in the for the building. And so there's another way to do it and to have air cooled parts where we're sending the refrigerant out to this condensing unit out here. And so we're kind of separating. Uh, we have the evaporator section here in the building and the condensing side outside. So it's air cooled condensing. But it's just a different type of chiller. And so I chose a liquid cooled chiller as what I'm going to talk about in in the final report as my example. But this is another version of air cooled chiller. Okay, and I think you've seen these before. We've talked about this before, where there's a fan and the refrigerant's going around in this around the coil, and anyway, just a whole bunch of like individual condensing units that are all packed together. And it's a bigger version of it, but we've talked about it in other classes. But here is a cooling tower, and the cooling tower is doing exactly what we talked about, has water, and it's cooling off water, and it's actually sending water over to, go back to PowerPoint here. Here's the other way to do it. Remember I said this air handler has two cooling coils. That one right there, that coil, is directly from that cooling water is directly from the cooling tower, and this one is from chill water from a chiller, but it's an air cooled chiller. So I don't know that this is really hard, but I know that it could be very difficult because Michael's talking like chill, cool. Uh, this schematic, I know, but really this is just like a big swamp cooler, and this is the coil inside the air handler being fed from a chiller that works with the same refrigerant cycle, but instead of cooling off air, it's cooling off water, sending water to here. Anyway, hopefully I've given you enough options there for chill water could be. All right, this is what the final says. So you're supposed to report on two MEP related systems or components. What do I mean by systems or components? I was just giving you an example of one system with two components, and that's fine. Or you can do two different systems. So let me give you an example of some systems. So uh, last semester, somebody did a report on a recirculation hot water system for a home, so that whenever you went to like a faucet and turned on the hot water, it was immediately hot. And so it was a residential uh, hot water recirculation system. That was fine. It was relatively small. There was not enough big components. Really, there was only one component in it. It was a pump and some switching controls to be able to do that. So that was one of his two things that he reported on. Uh, Another good example of another small system would be a man. The word is just water softening system. Sorry, a water softening system. For a residence, they're not very complicated. There's only a few components in it, but that's a good system. It's small. It's still something that could be described on how it works, and so that was a good one. The now the You could do something like I did, take a larger system, which is chill water system, and pick two main components and describe what those two main components do. So, or make a report on those two components. Okay, so I don't care what the file format is, but I would describe the final to look something like this. You're gonna have a some written part, which I would want with both systems being reported on, a page and a half, whatever this type of spacing is that you're seeing on my screen right now. That's enough. I think it's double spacing. I don't think you're going to get enough detail in it with like that double spacing or whatever it's called. But um, if your formatting looked like this, I would think a page and a half would be enough to describe both of to be your entire report of the narrative. So let me describe what's in the narrative. You're going to describe the system in a few paragraphs. What does the system do? How does it work? And then I'm telling you right here, watch manufacturers' videos, watch literature on YouTube, look at literature, download it. I'll show you how I did that in a second for the two components that I did. So you're basically describing how the system works in your own words. And you've had uh, uh, other assignments where you've had to do that in a few paragraphs. Write out what the how this thing works, right? Same kind of thing. Whatever you want to report on, and you need to have two of them. You need to report on how that works, and then describe what logistical. This is construction management, so the other part of the report is to consider the logistical things like procuring materials, how they're going to get to the job site. Is there anything specific we need to install them? And in this, I wrote down that it takes experience to know. So some of it you're going to need to get like YouTube videos, maybe of installation of it. Uh, See if there's anything specific. Um, just think through if it's a large components like a chiller and a cooling tower. Those are both set with cranes or maybe forklifts or something like that. They're a long lead item. So I would be describing some of that in my narrative as bullet number 2 about the cooling tower or about the chiller. And so bullet number 3, describe in a few paragraphs the coordination that is needed for the construction work to be done effectively, right? And commission the system. So let's go back to my little simple diagram here. My report is about the chiller and the cooling tower on a chill water system. So this uh, the sequence of construction is actually piping. This probably wouldn't go in place before we did the structure, the piping, probably some electrical, and get some controls roughed in, and then set this in place, and then make the final connections. Same thing with this. So we would probably do some structure or underground piping or above ground, whatever it might be. And we're going to have to do some piping first and then probably set this in place, rough the piping over to it, set this in place, and then make the connections. Now the commissioning side is there's a lot of individual startup things that need to be done with pumps and motors and things like that. There's this whole chiller would need to be started up, and that would be more like the idea of just getting power to it, making sure it's working, but it's not going through its functional performance testing. But to think through this system, we need uh, the cooling tower to be operational before we can really make the chiller operational. Do you agree? Because how are we going to make this condensing side work? We also need to be able to put the chill water somewhere and lose that and make that chill water come back hotter. So we need what's called a load. So we need at a minimum an air handler operational, the cooling tower operational before we can make the chiller fully operational. And I would want that narrative out a little bit. So just say the and I would write that in my report about uh, this description about what needs to happen during construction, and then what we need to do on commissioning the system. When I say commissioning the system, it's startup, testing, things like that. And so it's not an independent components. When I was talking about the chiller, the chiller can't just start up by itself and be working. It needs a cooling tower, and it needs to be able to have a load. So it needs the air handler, right? So that's what I need to describe. And I gave you an example like the kitchen sink. Think through the kitchen sink assignment. When we had the kitchen sink, how many systems were really needed? And so on the chiller side, uh, if I started thinking about all the things that are touching it, um, well, the cooling tower and the air handler, those are the main things. We have a makeup water on the cooling tower. We have power. We have controls. There's no natural gas for the chiller or anything like that, but there are expansion tanks. There are um, uh, glycol feed tanks. There's pumps and motors, so there's a lot of electrical. So I could think of a lot of things that I could write in here that need to be part of the system to make it completely function, to make it completed, right? So maybe I make a little list in there. Maybe I make that into a narrative or something in my report. But sometimes, and this is kind of one of the points of this lecture right here, is there's something in the lecture that you don't, or something on the components that you don't quite understand. And that's fine. So making a list of things that I don't quite understand. So for instance, there's on the chiller that I picked out, go back to my chiller. Um, why did I do that? Okay, here's my chiller. It's got a heat recovery piece in it, an option in it. As I was reading through this literature from the manufacturer, it's got uh, it's got this loop where we have the option on the condensing side to take some of that hot cooling water and go use it for heating loads before it gets back to the cooling tower, which I thought was interesting, but I don't know much about it. So if I was to describe what I want in the literature, I would say I also read in the literature that there's a supplementary side of the heating load that you can use for the excuse me, the condensing side of the chiller, which I don't quite understand. So 1, 2, and 3 should be written about each of the systems or each of the components within a system. So I need to do a cooling tower, and I need to do the chiller, and I need to answer these questions about both of those systems. If they're very related, I'm smart enough as you write this, if you say like both of the both of the components work together, and so you could write about them all together in number one, as long as you were writing about how both of them work in number one. So I need to talk about how the chiller is using the refrigerant cycle. I need to talk about how the cooling tower is cooling water through evaporation and how they work together. And I could put that all under number one, or I could separate them. I don't care. Just make sure that you're describing both of these things about both of your use one, two, and three. Make sure you describe one, two, and three for both the systems or both the components within a system. And then it says provide a schematic drawing of the system. Now, most MEP equipment provide a simple schematic. So I don't care if you make your own schematic like I did right here, or you could find it online right there. Literally, that's the schematic. There's the cooling load, meaning that's the air handler. And my report's not about an air handler, it's about the chill water system. And so that's a schematic right there I could have used. There's other stuff online that I think is really good, and I'll show you here in a second where you could do. But back to this. So you need to provide a schematic of the system, provide submittal information for the system or the component. Okay, so if you're doing, for instance, the hot water recirculating system, find the manufacturer for one of them, print off their product data, and it's fairly simple. I mean, you can get to. So I went to Trane's website. I knew I wanted to do a chiller, so I did Trane chillers. Went to their website, downloaded. What did I do? I think I did the catalog of this chiller right here. Downloaded it, or I didn't. Downloaded that one right there, which gave me this right here. That's basically the product data I'm looking for. That's fine. So I want, and then I save this to my computer. So I have my simple schematic. I have my chiller product data and my cooling tower product data. Here's my cooling tower product data. And there's a lot of pages to it. And there was a lot of pages to the chiller. So going back to the final, we want a narrative, a schematic, and then the product information from the manufacturer. And upload all of that back into Canvas, and we should be in good shape. So I left a bunch of possible things to work on, to report on. It doesn't have to be this. You could go. There's a lot of like systems within uh, like related to sustainability that you could do anywhere. Could photovoltaic, you could do that. That's anyway, lots of things you could do here. Just pick out something you think is interesting, do some research on it. Let me show what I did on one of the recommendations I have. Like if you pick uh, read through things like this, there's people online that do all kinds of stuff. Use your book. Your book might have what you're looking for. Obviously, I've throughout this entire course, I've tried to show like use of the internet, use of manufacturers' literature, use of like Home Depot. If you're buying something from Home Depot, usually they have all kinds of
condenser via a refrigerant loop. The
check
condenser
this guy out.
absorbs this heat
I like
and
this
then
dude.
dumps this
He does a
into
really
the
good job.
condenser water loop. And this runs between the chiller's condenser and the cooling tower up on the roof. The cooling tower will force ambient air.
Right, so he's got the chiller down here, the cooling tower there, and the air handler there. So the chiller on the condensing side, it's taking the heat away from the condenser, putting the water into this cooling tower. wasting the heat there, uh, which cools off the water enough to go cool off the condensing some more. And then he's got on this side the evaporator side, and the cooling water. I can't tell from his graphic.
Air across the condenser water to extract the unwanted heat and reject this heat out
Yeah,
of
the
the building
blue
and
in
into the
his thing
atmosphere.
is
So in this instance, the
the
condenser
supply,
of
and
the
the
chiller
purple
has
is
been
the
cooled by
return.
water, so it is now
Pretty
a
cool, right there.
water-cooled chiller.
So that is that's the final. A written part, a schematic, and the product information for what you're describing. Two things. So you either do two components in a system or two different systems. Okay. Have a great day, guys.